Hello and welcome. My name's Alex with AlphaStar Academy, and today we're going to be solving contact tracing 2, the second problem from the December 2023 USACO Bronze Contest. So here's a quick summary of the problem. We have N cows in a line, some of whom are sick. So for example, 0 are the healthy cows, 1s are the sick cows, and sick cows spread their illness to their left and right once a day. So if this cow started as sick, on the next day, it would spread its sickness to its neighboring cows, and then on the next day, these two cows would spread their sickness to their neighbors, and so on. And what we want to compute is, given the final distribution of sick cows, what is the minimum number of cows that could have started sick, right? So here, if we had this sort of group where we had 5 sick cows here, 7 sick cows here, and 3 sick cows here, then the minimum number we would need to start being sick is 4. In particular, these 4. And we can make some simple observations. The minimum number of cows that are going to be required to make a formation is at least the number of different intervals, right? Because so say I have a situation where I have 2 intervals of sick cows, right? So this is an interval of sick cows. This is an interval of sick cows. There's no way for a singular sick cow to produce both of these intervals, right? Because there's a gap between them. And if a sick cow had produced both these intervals, then there wouldn't be this gap, right? So because it always spreads to the left and right. So a different cow must have made these guys sick than these guys. Then the question is, okay, well, it's not just the number of intervals, right? So we could see in this test case that there's this interval which had been spawned by 2 sick cows. The question is, why did this interval require more cows than this interval or this interval? And the key idea here is this interval was bigger, so it either needed more cows that started it or a longer time to reach this, right? So if we had more time, then we could have started with 1 cow and produced this interval, right? So if we had 3 days instead of just 2, we could have done something like this. So let me copy and paste this real quick. So we could have had something like day -1, and then we could have started with a cow here, and we could have started with something like this. So then this cow is going to start expanding and spread to the entirety of this length 7 interval. But the problem with this, why isn't this allowed? Well, we are constrained by our smallest intervals. So key observation, size of our smallest, in some sense, right, we can't go any further back in time than when these intervals sort of reach 1 cow, right? So these intervals, they've reached 1 cow. They can't go any further back in time. Someone had to get sick on day 0 in order to produce this interval. And there's only 1 cow that could have done it, this cow. If we go further back in time and I place a cow right here, well, then that actually would increase the size of my interval, right? It would expand the interval, and now all of these cows would be sick. So the size of our smallest interval tells us the maximum number of days that the simulation could have been going on. So size of smallest interval determines number of days that have passed. In particular, the maximum number of days that have passed, right? You could always have 0 days passed where every cow started sick, but in most test cases, it's probably not going to be optimal for every cow to start sick, right? That's sort of the worst case possible. So the first thing we want to figure out is the number of days that have passed, because that's going to let us calculate, using the size of these intervals, sort of how many cows we need to produce that interval. So for example, if 3 days have passed, how many cows do we need to create an interval of, let's say, 7 sick cows? Well, we already saw that it was 1, right? So we could do something like this. But then if 3 days have passed and we wanted to make an interval of 9 sick cows, then we would need more cows, right? So we'd need to add another starting cow here, which is going to make these cows sick, right? So the number of days that have passed determines how many cows we need in order to create a certain interval length. So the key element here is looking at the interval lengths. There are a few edge cases. So edge cases. And the edge cases come from the cows who are on the end right here, right? So these two things, they look like different length intervals, right? So this looks like a different length interval than this guy. But the problem is because this interval is right on the edge, we could have a cow start getting sick on the edge, and it would take longer to spread, right? So we do want to sort of think about how to deal with these edge cases in the future. But right now, let's sort of just try to get a map between how many sick cows there are in an interval and sort of the maximum number of days that could have passed to produce that. So if there's 1 sick cow in an interval, then obviously 0 days, the max number of days that could have passed, so this is max number of days passed, that has to be 0, right? This cow can't have spread it anywhere. Similar for 2 cows. We also get 0 days have passed. Why 0 days? Well, if more than 1 day have passed, then the minimum length of the interval is going to be 3, right? So if I have 1 cow, 1 day passes, now 3 cows are sick. If I have, say, 2 cows and 1 day passes, now 4 cows are sick. So in both these cases, we'll see that 0 days have passed. Note that it's very important that these zeros are here, right? So we already talked about the fact that there is an edge case where if an interval of sick cows is right up against the edge, then the story could be different. But let's just, for now, think about the standard case where there's a 0 and a 0 to the left and a 0 to the right. As soon as we get up to 3 cows, then the max number of days that pass to produce this interval is 1 day. Why 1 day? Well, we could have 1 cow, and then that cow spreads its sickness left and right to produce that interval. So 1 day. Similar for 4. How do we get 4? If we start with 2 sick cows, and those sick cows spread left and right over the course of 1 day, we end up with 4 sick cows. So this is also 1 day, right? If 2 days have passed, we will never see an interval of length 4. If 1 day has passed, we'll never see an interval of length 2. If 1 day has passed, we'll never see an interval of length 1, and so on. Then we can continue the pattern. So 5 would be 2 days. How do we get 5 in 2 days? Well, we start with 1 sick cow. It spreads it to the left and right over 1 day, and then it spreads it to the left and right over another day. We end up with 5 sick cows. 6 sick cows will be 2 days. 7 sick cows will be 3 days, and so on. And by now you should start seeing a pattern. And the pattern is every time we increase the length of the interval by 2, the number of days the max number of days that have passed increases by 1. So if L is the length of the interval, say interval has length L, then max number of days passed is exactly, at most, L minus 1 over 2, where the over 2 here is integer division, right? So this is L minus 1 over 2 rounded down. So if we had some arbitrary arrangement of sick cows, we could calculate the max number of days passed by looking at all the interval lengths for the sick cows and choosing the smallest one. Okay, this is the smallest one. Okay, if I look at the smallest one, what does that tell me is the max number of days passed? That's going to be 1 for 3, right? So we saw that 3 sick cows in a row meant 1 day had passed. And this is great. So we can now calculate the max number of passed. How does this help us, though? Well, using the max number of days passed, we can calculate the minimum number of cows required to produce each interval. So in this example, we saw that the max days passed was 1 because of this interval. And that implies that we need at least 2 cows to produce this interval, right? So we need 2 cows to produce an interval of length 5. In particular, how can you produce an interval of length 5 in 1 day? Well, you start with a cow right here. You start with a cow right there. They both pass the sickness to their left and right, and you wind up with 5 sick cows. So that's possible in 1 day. Now here we have a length 7 interval. If we only get 1 day, we need to start with 3 sick cows to produce a length 7 interval. Right, so here we're starting with 3 sick cows. They all pass to the left and right. We get a length 7 interval. So the sort of starting position would look like this. How about a interval of length 4? We'd need 2 cows for that. So we need a cow to pass it here and a cow to pass it here. And then this is just 1. So in total, we have 1, 2, 3, 4, 5, 6, 7, 8 cows. So minimum number of cows needed, 8. And we basically want to replicate this in code. But one thing that we're going to have to worry about with this problem is the number of cows here is quite large, right? So it's up to 300,000. Because the number of cows is quite large, we need to be able to calculate sort of the minimum number of cows needed quite quickly. So we want to come up with formulas that convert the length of an interval into I want a formula that does the following thing. So I require a formula to do the following. Calculate the minimum number of cows required to produce an interval of length L given the number of days that have passed. And it's a little bit maybe tricky to just make this formula manifest out of thin air. But how you should approach this on a real USACO exam, you'd work through it by hand, right? So you'd write down, okay, this is my interval. How many cows do I need to cover it? Okay, that seems reasonable. And then you keep just moving on. So you run through many, many, many sample cases until you get an intuition for how many cows you need in order to produce the given length interval, given you know the days have passed. So, but we can sort of start from scratch, right? So we can say, we can look at, okay, how far does one cow spread? Well, we can see that the distance that a cow spreads is roughly twice the number of days passed. In particular, the spread of a single cow is 2 times the number of days passed, so max number of day, or let's just call it days passed, plus 1, right? So if we have 3 days passed, then the spread of that cow is going to be 7. 2 times 3 plus 1 is 7. So if I'm trying to cover an entire interval using as few cows as possible, I'm going to divide the length of that interval by the spread. So I'm going to do the length of the interval divided by the spread of a single cow, right? So this is how much space a single cow can take up in that interval. And this is going to be L divided by this rounded up, right? So if I have like one extra cow right here, even though that's really close to being covered by this cow, it's not. So we would have to add an extra cow just to cover this guy, which is why we're rounding up, right? So we're going to take the sort of number of cows that fit into the interval, so the spread of the cow, and then we're going to divide the length of that interval by this value and round it up. And this is going to be the number of cows we need in order to make everyone in that interval sick. And then we just loop over all of the intervals, calculate this number, and sum it up. So it would be sort of like this. So the pseudocode would look something like, step 1, calculate maximum number of days passed. Step 2, loop over all intervals and count how many cows are required to make everyone in that interval sick. So here are 2 steps. Let's see if we can implement them together. So we're going to begin by reading in n. So n is just the number of cows, and I'm going to be writing these solutions in Python just because I think those are the most readable. But you're welcome to use any language you want. And then we're also going to read in the cows itself, and we're reading it in as a string, right? Even though it looks like an integer, we're going to want to loop over it like a string, so best to leave it as a string. So next up, we want to calculate all of these interval lengths, right? These interval lengths are essential to the problem, so let's work through it together. So we're going to have an empty array called interval lengths, and we're going to then loop over cows and add up so we're going to loop over the cows. So starting here, okay, that's not a sick cow, that's not a sick cow, that's not a sick cow. Okay, we finally arrived at a sick cow. We'll start a counter, increasing it, increasing it, increasing it. Okay, we're now at 5 cows that are in this sick interval. Then we found a healthy cow. So we found 5 sick cows here. Add that to the interval lengths. Then we keep going, reset the counter. We find a sick cow. We go 1, 2, 3, 4, 5, 6, 7, and then we add that to the interval lengths. We found a new sick cow. We go 1, 2, 3, 4, add that to the interval lengths, and so on. So we can just do count is 0, and then for I in range n, right? We're just looping over all the cows. If the cows is 0, so cows I is currently 0, and the count is bigger than 0, this tells us that we have just finished walking over an interval of sick cows. So we're going to append to interval lengths the count and reset it back to 0. Then if on the other hand, cows are sick, right? So if the current cow is sick, then we want to increase the count by 1. So this is just saying, okay, I'm still inside my interval of sick cows. I'm going to increase my count by 1, and then as soon as I find the next healthy cow, I'll add that value to my interval. All right, and then we're just going to keep doing this until we've looped over all of the cows. And if at the end count is positive, that means we have one more interval we need to consider. So we're going to add interval lengths dot append count. All right, so this just keeps track of each and every interval length. Note, if you're working in Python, you can do this code in a much more efficient way, but feel free to experiment with the syntax here. I'm just trying to give it in a language agnostic format, right? So any of the 3 languages, C++, Java, Python, should be able to replicate this code. So you won't see me using too much language specific notation here. The one thing you do want to watch out for is I'm using dynamic arrays. So these are default in Python. If you're in C++, you will want to use vectors. If you are in Java, you will want to use array lists. So these are just arrays that can grow and shrink depending on the number of inputs you want to provide to them, right? So in Java and C++, for the most part, if you just use the basic array, it's a fixed length. Here, you're going to want to use vectors and array lists in order to get this append functionality. All right, continuing on, we want to calculate the max number of the max number of nights or days that have passed. So we're going to have max, let's call it days. And there's one thing that we didn't account for when we were originally working out our solution, and that was the two leftmost interval, the leftmost interval and the rightmost interval. And the problem that occurs with these two intervals, as we saw earlier, was this interval has a slightly different formula. In particular, we can see that normally to calculate the max number of days passed, we just do L minus 1 over 2. If an interval is touching the edge, in particular, there's no 0 over here, then the formula becomes L minus 1 instead. So in order to amend for this, we're going to do the following thing. We're going to take the minimum of the first interval and the last interval and subtract off 1. And this is going to be our start value for the max number of days that have passed. L here, I'm just denoting as the sort of number of intervals. So L is the number of intervals. It's just the length of interval lengths. However, sometimes the leftmost interval or the rightmost interval isn't on the edge, right? So if there was a 0 here, then this is not part of that special case, and we want to use the first formula we calculated. So we're going to want to check if this 0 exists and if this 0 exists. So we're going to do left 0 is equal to cows 0, 0, right? So if this is true, that means there's a 0 to the left of the leftmost interval. And right 0, if this is true, then that means that there's a 0 to the right of the rightmost interval, right? So it just checks whether or not this 0 exists. If this 0 exists, then we want to use the original formula to calculate the maximum number of days that have passed. If this 0 doesn't exist, then we're going to keep using this formula. So we can do something like if left 0, then the max days is going to be the min of max days and interval lengths 0 minus 1 over 2. And I'm using 2 slashes for integer division here. But in C++ and Java, it's just 1 slash. Likewise, for the right 0, we're also going to check if there is a right 0. If there is a right 0, then we want to use, again, this formula for calculating the max number of days passed. So max days is going to be the minimum of max days and the interval lengths, the rightmost interval length minus 1 over 2. All right, so this is taking care of the edge case where this leftmost, or this rightmost interval or this leftmost interval could potentially be bordering the edge of the cow's array itself. So again, just to clarify this point, if I had this interval, then I know that sort of the number of days passed has to be 1, right? Because this one cow spreads to these 2. However, if that left 0 didn't exist, then I could do something different. And I could actually take 2 days to spread the sickness to those 3 cows. Because I start the cow all the way to the left, and then on each subsequent day, it only expands by 1 unit at a time, rather than 2 units at a time. So that's why if these left and right zeros are not present, my max days is actually going to be a little bit larger, right? So the formula here, so using formula max days is equal to length of interval minus 1. And then here, we're using formula max days is equal to the length of the interval minus 1 over 2. So, but these are conditional on whether or not this 0 exists. So if this 0 doesn't exist, we can take more time to produce that interval. If this 0 does exist, we're going to sort of run out of space faster. So we're going to have fewer days, which is why this number is smaller. All right. Now that we have the left intervals and the right intervals dealt with, we need to actually account for all of the other intervals. But those are a little bit easier because all of the other intervals, they're just going to use this formula. There's no edge cases here because they're in the middle of the array, right? So there's no possibility that this interval is going to have that same sort of boundary problem where there's the size of the interval is only growing by 1 at a time. If you're in the middle, you're always growing by 2 every single day. So key idea, intervals in the middle always expand by 2 cows every day. It's a rule. All right, so we can calculate then by just looping over all the remaining intervals and calculating the minimum of the length of all of the intervals minus 1 over 2. So for I in range 1 to L minus 1, max days is going to be the minimum of max days and interval lengths I minus 1 over 2. And again, we're using integer division here. All right, so that is step 1 completed. We have now calculated the maximum number of days that have passed, we now need to move on to step 2. So we're going to loop over every single interval. And, oh, whoops. Let's not delete step 2. All right, so step 2 is back. We're going to now loop over every single interval and count how many cows are required to make everyone in that interval sick using the max number of days passed. And remember, the idea here was the spread of a cow is exactly 2 times number of days passed plus 1. So therefore, if we start our count at 0 here, we loop over all the intervals, and we count. We increase count by the length of the current interval divided by the spread of a single cow. So that's just 2 times the max days plus 1. And then we round up, right? Because as we talked about earlier, if we had a situation where we were just shy of the sort of the number of cows we need, right? So if we've spread to 3, but we wanted to spread to 4, right? If we wanted to spread to 4, right? So say we had something like, or let's actually do a slightly larger one. So we've spread to 5, but we wanted to spread to 6. Right, so this guy almost spreads. It spreads to these guys, but it misses out on this one just barely. We will need that extra cow. So that's why we're rounding up here. Easiest way to round up is if interval lengths I is divisible, or is not divisible rather by the spread of the cow. So that's just 2 times the max day plus 1. Then we should increase it by 1. So count gets increased by additional times. So this is, if it's not perfectly divisible, then we're going to increase that count by 1 to make sure that whatever portion's left over is being accounted for by some cow. And then we print out the count, and we are ready to debug our program. So now our program's a little bit more complicated than in question 1. So we might have more bugs. So let's submit it and see if any bugs arise. I know for certain there's going to be at least 1 bug in this program, but let's see what happens. So we've submitted our solution. We'll run it. And grading. All right. So first of all, we have just an integer division problem. That's an easy fix. Let's save that. And let's go back here. So we're going to submit. All right, so we're passing a large majority of the test cases, but we're failing test case 3. And an interesting thing about test case 3 here is not only are we failing it, we're actually getting a runtime error. So you want to think about, okay, so my program works great for 11 out of the 12 test cases. Why then is it failing for test case 3? Right, so my program almost always works. What's going on in test case 3? So why am I failing test case 3? Obviously for USACO, we can't see the test cases, but you should want to think about edge cases you didn't consider. And in a problem like this, a very popular sort of sample input that they would give you, so common input, would be the case where no cows are sick, right? So if they just give me a long array with not a single sick cow in it, my program's probably not going to fare very well against that test case. In particular, things like interval length 0 implicitly assumes that there's at least 1 interval of sick cows here. So in order to fix this, I should check for this sort of test case and make sure that I sort of exit my program early if I'm in the case where there are no sick cows. Because if there are no sick cows, I immediately know what the answer is. So I immediately know the answer is going to be 0. So if no sick cows are present, print 0. So that's pretty easy to add to the program. We just do if 1 is not in cows, then we print 0 and we exit, right? So exit is sort of like a break statement for your entire program. It'll just end the program early and not run anything down here. So let's save our program one more time, try submitting it to the grading server, and I think this time we will be totally bug-free. So let's run this, and we can see we now pass test case 3. Always important to think about, okay, what sort of edge cases am I missing? This is a pretty common one to spot where they give you no sick cows. So edge case, no sick cows. And this problem is actually pretty similar to an old USACO question. So just as a fun note, this is very similar to the 2020 open question, social distancing. It's maybe a little bit easier than this question, but if you've solved this problem before, you definitely notice some of the similarities between how we went about solving this question and how you solve this question. So on that note, happy coding, everyone, and best of luck on all future contests. Bye-bye.